Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by Cachefly at CACHEFLY.com. This is Floss Weekly with Randal Schwartz, episode 116 for April 10th, 2010. eLua. Floss Weekly is brought to you by Drobo, the original S Pro, and the new Drobo Elite, offering expandable storage products for individuals, small businesses, and creative teams. For more information and instant rebates, visit drobo.com/floss. It's time for Floss Weekly, the story of free, libre, open source software, as told each and every week by our hosts. Mr. Randal Schwartz is here this week. Hello, Randal.
Hey, Leo, good to talk to you again. And for those watching at home, you can see that I'm once again back in the home with the giant stained glass behind me and the giant blue Yeti in front of me. So the voice is a little different than you heard last week.
When you hear Blue Yeti, though, don't think Abominable Snowman. That's the name of his mic. He's named his mic, folks.
It has a Yeti logo on the side.
Yes, it does. So, Randal, good for you on getting a job.
Yes, that was exciting. Yes,
Yep.
it's and actually, I'm just taking a quick break from my day job. I work remotely on the weeks that I'm not actually there, so I'm actually just taking a little bit of time out of each Wednesday to come chat with you guys, and then I go right back to working for the guys on the 44th
For the
floor
man.
downtown LA. Yes, good thing I wasn't there on Sunday because they had a big earthquake there. So.
Yeah, I know. We were doing Twit, and Jeannie Jardin, who was on the show, said all of a sudden, "Hey, the Earth is shaking," and it ain't my iPad. John O'Bacon not with us this week. He is he's in the sunshine, but he will be
Somewhere
next
on a
week.
beach.
Actually, you guys are going to switch flip-flop because he'll be hosting next week.
Yep.
And one more thing to say is this will be the one show on the entire Twit network in which you will not hear a word about the iPad. So you have entered an iPad-free zone, my friend.
Because I don't have an iPad yet.
Well,
so
and it's not open source. It's kind of the antithesis of open source, actually.
I talk about my iPhone.
True.
So there, it's okay. All right,
Kermie. Who are we talking to today?
Well, it's embedded. We're in bed with it. No, it's embedded in that we're talking about embedded Lua.
He said
eLua. Now, we've talked about embedded projects before. We had Bug Labs on a while back, and that was a little Linux box that had these peripherals that you could pop in on the side. And we talked to the Arduino guys, which is they ran a version of C++ called Wiring to be able to program them, and there all sorts of different projects being done with Arduino. eLua is a Lua language, and I think you know a little bit about that, and I know a little bit about that. Not much. I think you know a lot
I actually
more
got a book on Lua because I was so interested in it. It's a programming language. I know they use it to control games. It's kind of, it's like Perl or another scripting language. It's often used for glue code. So you might take different modules and glue them together with Lua. It has the advantage of looking very much like, a modern C-style programming language.
Very, very high-level language, fairly recently developed, from what I understand. Like
it's Portuguese. Lua is a Portuguese word. I don't know if it's Brazil. I presume it's Brazil.
It was made in Rio. I mean,
Rio.
It's one
That's
of those
cool.
crazy things to come out of Rio, So I've been to Rio, so I can imagine them developing languages there. So it's all very good. It's been used in a lot of different applications. I mean, if you've played World of Warcraft, you've probably done some Lua scripting or a bunch of other stuff.
You might not even know you're using Lua.
Yeah, or Lightroom. Lightroom is mostly.
Lightroom's entire. I think it's written in Lua. Yeah,
it's written, at least the user interface parts I think are written in Lua. Yeah. So what eLua is taking this and making it possible to run it actually in one of these small boards, kind of like we had with the Arduino board or the Bug Labs board. It's a small machines that have like 64K of memory. I mean, tiny little machines. And used for all sorts of different things.
Embedded applications. Well, we're going to get our guest on in just a little bit. He will be talking about it. His name is, I guess he's on the team, Snyder, James Schneider. But before we do, can I mention a sponsor? Believe it or not, we have a sponsor.
A sponsor?
Yay. I'm very happy. Very happy.
Cha-ching.
Well, I don't know about cha-ching, but at least... You know what it means? It means that there are companies out there who believe in the open source community and are glad to support the show, and I would include in that Drobo. DatoRobotics.com. You know about the amazing little Drobo.
Mm-hmm. I have one right here, right by my phone.
Are you a Drobo user? Me too.
Every morning I back up my laptop to my 4 terabyte classic USB only Drobo that I picked up a couple years ago because the deal announced on MacBreak Weekly.
Yeah, well, we got a great deal now on Floss Weekly. If you go to drobo.com/floss, there are deals on all the Drobo models. Let me give you a quick rundown of the different models because there's some new stuff, some very new stuff. We've talked before about the original Drobo, which is the one I use at home, probably the one you use too, 4 disc bays. And of course, the beauty of it is you can mix and match drives, unlike a traditional RAID array. If you put in 160 gig, a 500 gig, a terabyte, and a terabyte and a half, it'll add them together. It won't just take the lowest common denominator. It reserves about a third of that space for redundancy. That's the other thing. It uses its own kind of redundancy so that any one of those 4 can fail. You just put another drive, it rebuilds itself, and you've lost nothing. I love that. Then they went to the Drobo S. That's got 5 bays. Any 2 can fail. The Drobo Pro with 8 disk bays. Now, with current drives, that means you can get up to 16 gigabytes. But I think that the limits on the actual Drobo are much, much higher. I can't remember how much data the Drobo is capable of, but it's far more than the existing drive situation. So I think you can go up to terabytes and terabytes, several. I can't remember what it was, 24 terabytes, something like that. And the newest model, that's what it says here, but it isn't the newest model. The next to newest model, the Drobo Elite, that's 8 bays. It's a SAN supporting up to 16 computer connections, 2 gigabit Ethernet ports, connecting a host using iSCSI, which makes it look like a local drive. This is great for virtual machines. It's VMware certified. It's great for anytime when, like our video editors, where we have multiple people using the same files on the same machine. That's the new Drobo Pro or Drobo Elite, and now they just announced a couple of days ago, and it's actually not in the ad copy, so I'm just going to throw it in because I think it's so cool. The Drobo FS File Sharing Edition, which means you can share data on a gigabit Ethernet network. Mac, Windows, Linux, Unix. It has 2 processors so that you can run Linux software on it directly. I can go on and on and on. Here's what you want to go do. You go to drobo.com/floss, and you will get a list of, that's the coupon code FLOSS, discounts that you can get from $75 to $500 off when you purchase your Drobo. They're all in there. The Drobo S, the Drobo FS, the Drobo Pro, and the Drobo Elite. 16 terabytes. That's the max capacity on the Drobo Elite. Unbelievable. Take a look. We are fans. I know you will be too. And we thank them so much for supporting us and open source software. drobo.com/floss.
DROBO. Drobo. Feeling droopy.
That's me. I'm feeling droopy. It still feels like old time radio when I play those. They're just silly. They don't tell me to play them. I just have them. Paul Minshaw made that one for us.
Such a great little jingle.
I just love it. Are you ready? Let's talk to James. James Snyder on the line. Ready here to talk about eLua. James Snyder, who is currently a Northwestern University grad student in the biomedical engineering department, going for his doctorate there. James, welcome to Floss Weekly.
Thank you. Thanks for having me on the show to talk about this project. Should I get right into it, or?
Yeah, why don't you explain? I mean, I think we talked a little bit before we brought you on about Lua, because I've been playing with it. I got the book on Lua, and World of Warcraft can be scripted in Lua, and there's a lot of uses for Lua. What is the difference between Lua, the language, and eLua, the project?
So eLua is a version of Lua that's based on that standard Lua distribution. So we take a copy of Lua 5.1.4 at this stage, and we make a set of modifications to it to make it a little bit more friendly to run on a constrained memory device. And other than that, it's actually a full implementation of Lua. So we have if you compile it and put it onto a microcontroller device, you have the parser, the lexer, the compiler, and the virtual machine all running on there. So you can take raw source code and put it onto one of these microcontrollers and run it from there.
So this doesn't involve any kind of operating system then. This is really the entire system running right down to what we call down to the metal then, right?
Yep, it's running on bare metal. Basically, just you have the startup code to initialize things and set up the interrupts and everything, and then it drops straight into our environment.
And what kinds of hardware platforms are we talking about?
So right now, we're running on a number of different 32-bit microcontrollers. We have 32-bit ARM. We have, which is a couple of different types. There's ARM7, TDMI, Cortex M3, and we might be running on one or two others there. I think ARM9. And in addition to that, AVR32, which is another architecture. And we also have a version that will boot on an x86 machine as well, although one of the main or key useful aspects of the project is that it has a built-in modules for interfacing with the peripherals you'd find in a microcontroller. So for the most part, you can play with it on an x86 machine, but it's much more useful on a microcontroller with some of the built-in peripherals.
Now, I'm not totally familiar with that level of small machines. Those are different processors then, right? Like ARM or the ARM processor, or are they all ARM except for the x86?
Well, most of the ones that I just mentioned are ARM. Okay. And they have a similar instruction set to the larger ARMs. And although they tend to be like some of the bigger ones that you might find in an iPhone will support a wider range of ARMs typically support a couple different instruction sets. There's the standard ARM, there's Thumb and Thumb 2, and okay. Like, for example, Cortex M3 just supports Thumb 2. AVR32 is another architecture that is a 32-bit microcontroller that's produced by the company that makes the chip that goes into Arduinos.
Mm-hmm. Oh, interesting.
So this is going to be there's some parts of what you're doing with eLua involve just Lua itself, so it must be high level and fairly portable. But clearly, there are some parts of this that are written in the assembly language of the target machine.
There's not too much assembler. Most of the main area where you might find that is just for the initial startup code, and that tends to be something that you can usually just get in some pre-provided by the maker of a given microcontroller, or you write it once, so we just use that as something to jump into our code. The rest of it is, for the most part, written in C. Lua itself is all compiles as ANSI C, mm-hmm. and most of the rest of the stuff that we've added on is written in C to try and keep the overhead associated with our additions as low as possible.
So C is still going to be more efficient then than Lua? Is Lua a higher level language then compared to C, I guess?
It's interpreted, right?
Well, it's a dynamic language. It is it's based around a virtual machine. Okay. So it's not you can compile it as a read, eval, print loop type environment like you can use with Perl or Python or with other languages. So you can just type in code and then get the response to the execution of that.
That's really handy for learning. I really value that.
Mm-hmm.
Right, but when you enter that in, it's actually it's not just evaluating that. It's compiling it into bytecode and then it has that that program or that object as something that it can then run later. So, like for example, also in this language, something that Randal might be familiar with is functions are first class. So you can they can be used as values like pretty much all the other types in the language. So you can assign a program or a function to a value, and then you can then later execute that.
Yeah, I was noticing. I have to say, I've stumbled across Lua a couple of times in my career, and not very much, and not to any great depth. But I was quickly skimming the Wikipedia page on Lua today to try to get up to speed real fast, and I really like the fact that it seems to be kind of an interesting mix. The object system seems to come from something more like JavaScript to have prototype based. And
right.
that's part of what you're talking about is this notion of actually having first class pointer objects so that you can or pointers to functions so you can actually do that sort of function manipulation. Why Lua then? Why Lua for this project?
Well, a couple of different reasons. One is that despite supporting a lot of these pretty useful features that you'd want to have in a language, it's actually quite small. And also the memory overhead is pretty low compared with some other languages that are similar in terms of being dynamic languages and having a number of these features. So if you can compile it on a desktop machine, and even in that case, it's about 150K for all of that that I was describing earlier. So you have a compiler, you have the virtual machine, and so as well as the built-in libraries that come with it.
And that's pretty important because these are really small systems, aren't they?
Right. So some of the devices that we're working with have about 64K of RAM, some a little bit less, although I would say for getting a reasonable amount of mileage out of a project like this, you'd probably want to have at least about 64K. And we do have a number of things built in that we use to help to fit Lua within that memory constraint.
Does Lua have libraries that come with it that you can flip off in case you don't need particular features?
Yeah, it does. It comes with a couple of built-in libraries. There's one for doing math functions, one for doing common file I/O. The functionality that Lua provides, aside from the core language features itself, the things that you get from various modules, tend to be the types of things that you would find in a standard C library, which is why it's able to compile as ANSI C. So it's about the scope of what you'd expect from just working with a standard C library as far as what those modules will give you.
I was just thinking back to the days when 64K meant a fully loaded system with an MSI 8080 bus or something. It was just like, oh my God, and 64K now we're talking about so tiny.
Well, I mean, you can still do plenty with it. It's you're certainly not going to run a copy of Word or anything like it in that. But
and that may be considered a feature, I think.
Well, I mean,
an actual benefit.
Right. Well, and one of the things about Lua that if you ever watch any of the discussions on the lists or communicate with people who are using it, they tend to be pretty pragmatic people. They don't tend to be too idealized. So they're, in terms of looking at the language, they see that it has value for certain types of applications, but they're not trying to push it into every little nook and cranny, even though, in this case, we're talking about fitting a language on these pretty small devices. But
so you started
go ahead.
So So I was just going to say, you started stumbling on the notion that that there are people out there actually using these things, and now I'm really curious. What are people using this for? That you inspired me there. What are people using this for?
Embedded Lua or
what people build with this? I mean, they're building devices, obviously.
I'm guessing robotics is a popular application.
I presume.
Yeah. So if you go to the User Labs website that we have up now, it's the wiki site. There are a couple of different projects that are linked off of there. One of the project leaders, Dado Sutter, has a lab down in Rio, and they have put up some videos of some of the projects that they've been working on there. There's a Segway like device that used to be a combating robot in a Riobots competition, but now it's they've adapted it a little bit, and they're riding around in the hallways with the eLua logo on it, and showing it off to the people on campus.
Cool. And so how does development happen on this? I mean, you're obviously one of the team members, or we wouldn't be talking to you. What's your relationship to the rest of the leadership of the community?
So the project was originally started by Bogdan Marinescu, who is based in Romania. He had worked on a project for a contest, and did some initial work on getting Lua running on a 16-bit microcontroller environment. Mm-hmm. And so he had put this up, and one of the other main team members, Dado Sutter, had found this, and he had been interested in getting Lua onto these small devices, because the idea is that instead of writing chunks of C code and then going through and compiling that, and then waiting for a whole minute for it to flash to a device, and then doing your testing, you could play with the language on the fly on these devices. So after a bit of time, the microcontrollers that were available started to have enough memory to run the language pretty efficiently, and once that was the case, they got it started as a larger project, and some number of months after that, I started participating on the list, and started contributing some patches, and eventually they gave me commit access, and ever since I've been
now you're in charge.
Well, I mean, at least on the level that
you want to volunteer? Great. Welcome.
I can put things in there and make modifications as I please, or at least insofar as if anybody tries to back out any of the changes. And also the three of us also communicate to sort of make plans about what we want to include in future versions and things like that.
Cool. You just mentioned something that hadn't occurred to me then, that because you have an interactive language, interactive high-level language, you can actually modify the code on the device if you have some sort of, is it like a shell that you have that you can talk to?
Right. So if you just take one of the default images from the site, I think in the video that you were just showing, it has you can put these like a specifically named script that it will automatically run.
This is a little Tetris game. It looks like it's running on an Arduino or something like that.
Well, it's running on. I don't think I have the same exact board as that one, but it's a microcontroller evaluation board like this. It's a Luminary micro board that has a little OLED display on it.
Oh, neat.
So the microcontroller is the device in the middle there. And then for these particular evaluation boards, they have a bunch of buttons and some LEDs.
So they come with eLua. That's their operating system is eLua.
Well, these boards don't come by default with it burned on there, although a number of manufacturers have been interested in it, and so they'll typically provide links over to our project so that when people are putting together their own devices based on these and evaluating the hardware, they can take a look at our stuff as an option for the software that would be running on it. Mm-hmm. But as far as the environment that you start up in, it'll by default come up into a shell, and you just access that over a serial link or over Telnet. Some of these devices have a built-in support for Ethernet. Mm-hmm. And from there are a few shell commands, or you can start up the interpreter and start playing around with Lua code from there.
So you could actually using the shell then, like type in the high-level Lua codes that say would wiggle the serial lines or change some of the LEDs off and on directly then.
Right, exactly. So you can either run larger programs that you've already pre-written, or you can just, you can play around with the peripherals there, make changes as you want. In addition to that mode, though, we also currently have an RPC mechanism that is tied to the way that Lua works. And what it allows you to do is basically the fundamental data structure in Lua is the table. And so you can put pretty much anything into the table, and any one of the types that are supported by Lua or types that you add. And you can index into sublevels of those tables by doing table name dot other table name or dot function so it's sort of like a hash table.
So the equivalent of a JavaScript object or maybe a Perl hash or a Ruby hash, I think. Right. Something like that.
Yeah.
Okay.
And so what this RPC mechanism does is it basically gives you a handle that sort of points to the remote Lua state that's running on an eLua board. So you can have a local Lua shell that you've started up, and you can set up this connection, and then you can assign variables in that remote session. You can call functions in that remote session. You can make aliases to functions and variables within that session, and then use them as if they were local. So it's sort of like an extension, treating the remote session as an extension of the local Lua state.
Wow. So a transparent distributed hash, essentially.
Mm-hmm. Yeah.
Wow. Very cool.
So you get results returned back to you call the function, and you can get results returned back to your local state and do work with them there. It allows you to do running the programs either, so you can sort of like make aliases to the various functions you might call within a program. And so you could have the main loop that you're going through iterating on your desktop, but then these aliases are being called on the embedded environment, or you can ship that whole thing over and just execute the whole loop on the device and only return if there's anything from that larger function.
Can you use that same protocol with multiple embedded boxes to create a sort of a high-level networking ability?
It should work for the way that it's set up right now. You should be able to do that pretty easily. Right now, it only works. It's set up to work over serial links, but it's pretty easy to extend it for working on other different types of networks. So if TCP/IP networking were added to it, you could have multiple devices on there, or if you're using a CAN bus or anything else that supported multiple devices, and have some networking going on between them where they're distributing work that they're doing or having other complex interactions.
What does my development environment look like for this? Do I have a simulator for my embedded box somewhere running on my desktop system, or is it always all done directly to the hardware, or something in between?
There's a little bit of both, actually. Okay. So you can do the development directly on the device, which we see as somewhat of an advantage, because you don't have to have a large, complicated tool chain. You don't have to compile GCC from scratch along with all the libraries that it needs, which is something that, I mean, for doing development on the project itself, you need, because you have to compile eLua. But for end users who are using just Lua itself, they can either use that shell environment, or they can use this RPC mechanism, or in the future, we're planning to have more of a GUI IDE to make it a little bit more friendly for people who are a little more command line averse. But the idea is that you don't have to have a huge number of prerequisites that you'll have to install in order to get this running. I mean, you can take one of these devices out of the box, you get an evaluation board or one of the development boards that we support, and you just plug it in, get eLua flashed onto it, and then at the very least, you'll have some sort of serial terminal program that's built into Windows or from the command line in OS 10, and you're already starting to work on it. You don't have to. You're not installing terabytes of programs.
Now, is there? I'm not, like I said, not very familiar with Lua. Are there IDEs for Lua itself and project managers, source code control managers for that?
Yeah, there are a number of environments out there. I think there's, let's see, so there's a text editor that's mainly written in Lua called TextAdept, and which is, they have a small stub that's GTK so that they can draw a window and be able to draw text on the screen and other things like that. And then all the other functionality is built on top of that in Lua. So it's a pretty flexible way to have a text editor, and that's actually one of the things that we're considering for maybe using for an IDE. There's modes built into things like Emacs. There's an Eclipse set of plugins. So there are a number of different things out there. And then as far as source management, it's and similar to working with any other language.
So it's text files, and you can just put it under Git or whatever you feel like doing.
Right.
Now, what kind of debugging support do you have? Do you have single step and watched variables and things like that at the Lua shell level?
So we're planning to have a remote debugger that will allow you to do the single stepping and things like that remotely. But as far as what we've got going right now, you get the standard things that are built into Lua. So if something bails and you get an error, it'll drop back out to the VM with the REPL, so you can still play around with it and get the trace for where it died, as well as whatever state is in there. When we put things together with an IDE, we're planning to maybe hook in with the single stepping and some of those other features.
Because I can imagine that, it's, I've often said that if you're single stepping a program, you're probably debugging it the wrong way, but I'll just take that back for this, because this is sort of the thing where you want to watch what's happening one step at a time on the low-level stuff, but it's nice to be able to do that. I'm sure people don't write programs that run their first time in Lua like they do anywhere other language, so just trying to figure out all the ways that someone would get to debug this.
Yeah, there's a couple of different sides to that. If you're writing stuff in C on one of these devices and if you crash, you've got some remote debugger attached to that, and in that case, then you can sort of catch things and sort of figure out where things are and what's going on. And in that case, you definitely do want to have the ability to be able to step around. Or if you don't have that, then maybe all you get are the states of the registers. So you end up having to look at the program counter and try and figure out where it was and what it was trying to do. But in this case, it's there might be, for more complicated applications, if you have things where it's not as predictable what layers you're going to be stepping through, it might be useful to have those features. But for the most part, it's since the cost to just putting in some code and giving it a try is so low, I certainly personally haven't found a need for having something that's single stepping through the Lua code.
Mm-hmm. Cool. What are classrooms adopting this at all?
Well, so we have down at in Rio at PUC, which is also the place where Lua itself was originally conceived of. Mm-hmm. They're starting to attempt to integrate the use of devices that are running eLua into some of the coursework down there. Mm-hmm. And we might have some things along those lines at the university that I'm at as well. I've been involved in some classes in the past where we've used other environments like Basic Stamp, and at least personally, I think there are some significant advantages to using an environment like the one that we're putting together.
I'm trying to imagine. I haven't yet heard of any other thing that had this level of a high-level language in the embedded space. So I'm thinking this has got to have some advantages for classroom use.
Right, because instead of just, in a lot of cases for debugging hardware is actually fairly expensive for these devices. So at least for some of the classes that I've taken in the past, you don't even get debugging hardware. So you end up using like LEDs to try and figure out, how far did my program get? It's like even sort of lower than using printfs all over the place.
Seven blinks, it got to the third subroutine. Yay!
It works, but it's not the ideal way to go, and you'd much rather be able to look at the objects that you actually have, when it blew up on something, so that you can say, oh, okay, well, I made an error somewhere here, or when I was reading something from that port, it gave me something that didn't make any sense, or something along those lines. It's a lot more interactive, and at the same time, it's reduces the amount of hardware that you need to be able to get that level of interactivity.
Very cool. And then there's obviously the hobbyist market. People are building little toy things and stuff, whatever with them, the tinkerers and whatever. Do you know of any like commercial applications that have adopted eLua in their results?
So there are a number of companies that have been interested in it, and there are again on the User Labs site on the wiki. I forget exactly on what page, but there's some mentions of some in progress projects. There's nothing out on the market at this point, but there are some things that are in the works.
Now, of course,
projects only. Oh, sorry.
I was just going to say that then begs the question: what kind of a license is this under, and would having that kind of commercial application be compatible with that?
Right. So the project is out under an MIT license. There are a few exceptions to that with some of the other libraries that we're using, but they're generally all under licenses that are about as permissive. We started out under a GPL license, but as far as getting commercial adoption, the MIT license gives a lot of flexibility for for people who want to use the project to use it for whatever application they want to without having to worry about having to also provide source code.
Mm-hmm. You just said you switched from GPL to MIT. I'm wondering, we just went through a very expensive relicensing process for Squeak, and I'm wondering, what was that like for your group, and how many different authors did you have to get to sign off on that?
Well, so the Lua source code is already released under an MIT license. So okay. that portion of things was pretty easy because it was already licensed that way. Most of the additions have been that have made it into the core of the project have been by not a huge number of people. So it wasn't like we had to track down, dozens of people in order to be able to make that adjustment. There are a few other things that we integrate from some other projects, like for supporting fat file system on an SD card, and that's under the license of the author of that. But for the most part, the things that make up the core of the project that are key to it are all were all pretty easy to get in under an MIT license.
And you just mentioned the fat file system. So apparently there's interfaces for storage, removable media storage and things. What are people using that for?
Well, for a couple of different things. For the most part, I mean, the easiest thing, or one of the most common things to use it for is just as an easy way to have some scripts on one of those devices. So if you have already flashed your device and you want to move over a bunch of code pretty quickly, you can just load it onto an SD card and then plug it into the device and run it on there. But also for things like logging data or providing larger data sets that you would want your program to be working with while it's operating. And then you just get sort of like a standard POSIX-like standard C library interface for reading and writing and seeking on that.
Are there GPS type chips available for some of the hardware?
Let's see. I don't think any of for the boards that we support, I don't think any of them have one that's integrated into it, but a lot of GPS devices have it sort of depends. A lot of these, for a lot of these different types of sensors and modules, you'll get something that'll give you pretty bare level access to what's coming out of it. But for a lot of the GPS devices, they have a pretty simple serial type interface. And so you can communicate with it just by powering it up and connecting the serial lines to the embedded Lua device, and then you can read and write over that line to get data from it.
So I'd start with one of the existing boards and add a little daughter board that would have my GPS on it and just have a serial line in between them then.
Right.
Wow, cool. Well, that sounds like fun, because I'm always looking at new different ways to have record where things are, and that I was thinking putting that together with the flash memory, that I can have like a little recorder that has a removable data set on it. Yeah. Exactly.
So you could stick a 4 gigabyte card in there and then log for, well, as long as you can provide power to it. Since just for coordinates as you're going along, it doesn't take up too much data space.
Right, true. Okay, so we talked about Lua earlier and why Lua, but I just the one other language that comes up in this space, it's a high level, low level language, is Forth. Why not Forth?
So there have been a number of projects that have used Forth. It's somewhat common to use as a pretty low level language when you want to have some level of an interactive environment that you can work with. But it also has the syntax for it and the programming model for it are, while definitely quite usable, aren't necessarily as friendly to less experienced developers and newer users. So Lua, the syntax of it is similar enough to other languages that are out there. I mean, in terms of the functionality it gives you, it has certainly a lot that's kind of derived from Lisp, although there are really pretty much no parentheses in it, except for, if you're doing logical operations and you want to, control order of operations for that. But it provides a syntax that's more familiar to someone who's worked with JavaScript or with C or other functional or procedural languages or even object-oriented languages. So it's easier to work with, and also since it's used quite heavily in games and in other places, it's more likely that people would have been exposed to it and have some resources to go to for getting some building blocks to work with it.
And I presume, like all projects, you have interest in having more people come and play with eLua and work with it. What any particular kinds of people that you're looking for making contributions to the project?
Well, we're looking for people at a variety of different levels. We'd certainly like to have more people who are doing development to help port it to additional platforms, to flesh out more device support and do things like that. But we'd also like to see more users that are just working on the Lua side of things and to provide examples of how to do various things like interfacing with different devices, different peripherals, for things like different GPS units. We have, if you look at the wiki, we have a couple of things there for using vacuum fluorescent displays, which have become somewhat popular in the last couple of years. But more things along those lines, driving little LCD displays and things like that, just so that it's easy when someone comes to the project and they want to put something together, having some examples of how to do that makes it a lot more friendly for new users.
So all you need is the skills then to write up a how-to, which is, not terribly necessarily long or crazy, just to have to be able to describe what happened and how I made it work, right?
Right, exactly.
Very cool. Coders, you need more C coders, more Lua coders?
Sure. I mean, most of the project is written in C. We have some chunks of Lua here and there. Most of those are sort of in some of the peripheral projects for providing examples and interfacing with peripherals in generic ways. So, like if instead of writing things in low-level C code, to write that in Lua so that it'll work on all the different platforms where we've implemented the layer to talk to our hardware abstraction layer.
Cool. And the source code for the Lua C parts and the Lua parts are all like on some repository somewhere using something like GitHub or?
So the repository is currently hosted on Berlioz. It's in Subversion. Although I'm personally a Git user, and both of the other project guys are, or a couple of the other project guys are in the RC right now, and I think they've been hearing plenty about Git for the past couple months.
So I sense a move to Git sometime soon. Then.
Yeah, that's. I'm not sure exactly when it will happen, but I think that in the grand scheme of things, we'll be moving to that. Just because for a variety of reasons, but I think it should be more flexible, and also sites like GitHub make it really easy or just hosting your own Git repository makes it really easy for people to grab your code and make some local commits, play around with it, and then be able to send changes back once they're a little more substantive.
And how about the maturity of the project? Is it useful now? Has it been useful for 5 years and we're just now getting around to talk about it? Or are we still sort of in some early betas of it and only for dangerous people so far?
Most of the releases that we've been making are actually pretty stable. Especially since we're basing this on Lua, which it has a pretty slow but deliberate release cycle, and the releases that tend to come out tend to be pretty solid. And then our extensions off of that, I'm sure that there are probably a few bugs here and there, but it's quite usable. It's quite useful at this point. The main things that might be more or less friendly are just sort of how comfortable you would be with using things over a terminal as opposed to having some sort of a GUI environment. So it just sort of depends on what people's backgrounds are and what they're familiar with.
Cool. Seems like a lot of fun, and I think it's easy to learn, and obviously something that would be very useful for somebody who wants to do robotics or any kind of embedded programming. If you go to YouTube, I found a ton of Lua videos, and there's kind of some cool stuff there, and a lot of neat projects out there. James, thank you so much for your time.
Thank you very much.
Great
Thanks
to
for
talk to
having
you
me.
about eLua.
Indeed.
Thank you.
eluaproject.net if you want to know more. Thanks, James.
Thank you.
See you later.
See you.
Well, that's fun.
And once again, something that now that I've heard about it,
You
I
wanna
wanna go take
play
time
with
and play with it. Yeah, I just want to start playing. Especially it's a high-level language. I like that. That's
Yeah,
so
you'd
cool.
you'd feel very comfortable. It's very C-like, very Perl-like.
I was looking at that. Yeah, like I said,
You asked the right question. I mean, Forth does is used in embedded stuff. It's all all of the above except that it's very compact, maybe even more compact. I mean, Forth are running 4K, not 64K.
Right.
But it's stack-based RPN.
Yep.
That confuses the hell out of young people today.
And what's 60K between friends, really?
Yeah, I mean nowadays
We can get
good
away without
Lord,
that.
there's more than that in the L2 cache.
I keep imagining 64K, and I remember I had an MSI 8080 that I built for the school that I went to, the high school that I went to, and we had 8K boards that were 1K by 1 chips. Yeah, so it's 64 in an 8x8 grid, and each hole held 1,000 bits.
Wow.
So to make 8K of bytes, you'd have 64 chips on this thing. And we had like 4 of these that I had to assemble by hand to get 16K of, let's see, 32K of memory, right?
Jeez. Well, that's in the old days when memory wasn't easy, wasn't cheap. Let me tell you something. I tell you whippersnappers. No, yeah. I was playing with Lua. A couple of things. Well, Adobe Lightroom is written in Lua, of all things.
I was just installing Nmap this morning.
Is it in Lua too?
It has a Lua embedded in it, so I can do extensions in terms of how to, search for and probe for ports and things like that.
So that's a useful language, for glue. It's a glue language. It's so there's a lot of use for it.
And I like what this project is doing with it again. It's like, I'm really not a hardware guy, but if I can get hardware sort of already there and then I can tweak it with software, I'm good at the software side.
Do you do any robotics stuff or anything like that?
Oh, if I had time.
Yeah, if I had time. There's the famous last words. What is it in your new job? Are you working in Perl or what are you working in? Squeak?
It's mostly Perl right now, though I'll be doing a lot of, it seems like I'm doing more things that are about Apache tuning right now than about Perl, but that's okay. It's just part of the project.
That's a black art.
Oh, it's going to be fun. It's an interesting thing. Speaking of black arts, let's talk about our upcoming guests.
Oh, we got a witch on?
What a segue, huh?
Oh, well,
I don't exactly know. John will book this guest for next week because I'm not going to be here next week. I'm going to actually be in Omaha, but I'll mention that in a second. Sam Ramji of Codeplex is going to be on. John is going to talk to him, and we talked a little bit last week about what that's about, and I've forgotten entirely because it's been a whole week. But I do know who the next guest after that is, and I know I've actually met him face-to-face a couple times. Sean Pierce is going to come on and talk about Garrett. Sean has been with the Git project since almost the beginning. He forked Git, created a Java clone of it so that he could connect the bug tracking system inherently with the Git archive.
Oh, how interesting.
Very good, being used by Android. So it's a big project being used by Android every day. So if you've done any kind of development on Android, you've come up against Garrett. We're going to have Sean talk about that. And then, still looking forward, 2 more weeks from now, Scott Maxwell, Piola Baluta, you may not know them by those names, but you know about the Mars rovers, and they drive it. That's their job every day. And so, at least until they get a flat tire or whatever they have now. But these guys are going to come on and talk to us about how JPL in Pasadena and how NASA in general is using open source software, and in particular, sort of how it's what fun it is to drive the Mars rovers. So that's going to be a really fun show. I'm looking real forward to that. We've got Matt Ray talking about Xenos, which is a platform for monitoring large installations, making sure all their bytes are up and running, boxes are up and running. Jonathan Simpson just booked recently. He's with the PDPC. I forget what that means, but they're the ones that bring you Freenode, which is the largest IRC network that all free open source software groups. Like right now, I'm on a Git channel. I'm on a FreeBSD channel, and I'm on a Perl channel, and they're all hosted on Freenode.
Yeah.
So, pretty much every open source project puts their IRC on Freenode.
That's neat.
It's there.
Yeah.
So this Jonathan Simpson is one of the senior guys with that. They also have this new conference coming up that they've just started called Geeknik, and another new conference just hasn't happened yet. I think it's going to come, the first one's coming up called FOSSCon. So these guys are into all really just figuring out how to support open source software in a way that really transcends in all the individual groups. I really appreciate the fact that PDPC is doing all this stuff. On the short list on twit.tv/floss, you can always find out who else is coming up. You can suggest people, follow the instructions there to email me and suggest people. Again, have the project leader write me. That's the fastest way to go right to the top of the list, like a lot of the recent guests did. They wrote me saying, somebody said FLOSS Weekly is great to be on.
Yeah, tell me all about it.
Yeah, so I just get to say yes and are available this Wednesday, and that's how they get on. So
easy.
Makes my job easy when we do that. I really appreciate that. You can follow me on Twitter at twitter.com/Merlin. If you do that, you'll see that I've been live streaming karaoke once again. I've been out there singing new songs. I take requests from all over the world that way. It's been a lot of fun. And you'll also, if you follow my Twitter feed this weekend, you'll see that I'll be at the Texas Linux Fest in Austin. I'm actually speaking as the closing keynote speaker for the first open source conference, the first, Texas Linux Fest, first Texas Linux Fest ever. So that'll be a lot of fun, talking about how I've contributed to open source over the years. We've also,
neat.
Yeah, and the reason I'm not going to be here next week is I'm actually speaking at Infotech in Omaha, if you happen to be nearby, but I'm going to be talking about all the different NoSQL databases that we've talked about, like CouchDB and MongoDB and Gemstone, and so I'm still preparing, I'll probably still be doing that on Monday. I'll be preparing this talk on that I had slotted in for 6 months on that one. I'm also going to be at the Dynamic Languages meeting that night, so if you're in the Omaha area, you can see me there. John is taking the show next week. You won't hear me. I will be gone. I will actually be at that conference. So I look forward to hearing that show, downloading it on Thursday.
Yay. And, of course, you can watch us do this live every Wednesday afternoon at 1:30 Pacific, 4:30 Eastern Time at live.twit.tv. And you can tell them what the UTC time is.
It's
20:30, I believe.
20:30 for the summertime, right?
Yeah, 20:30.
21:30 in the winter.
Right.
Yep.
See, he's so good with numbers. You ought to be a computer programmer. You're just fantastic.
Usually I jump in with that one. I go, oh, no, I don't want to do it wrong.
Well, my problem is I have to first convert it to 24-hour time. So it's 1:30, that's 13:30. Then I add 7, it's 20:30. And so that's what's going on in my brain.
Right. And I tell you what, as a pilot, that we had to do that all the time.
Yeah.
So I was flying, around in because every time it's like, your clearance is cleared at 22:30 Zulu. And I'm going, is that now?
What is that?
Yeah.
What time are you talking about? All right, Randal, what a pleasure, as always, to talk about open source software and how it's changing the world. I really, it's a great thing that you all are doing. So we're glad to kind of support that on Twit by supporting these great projects. We'll see you next time on FLOSS Weekly.